Area of surface of revolution, parametric form and a polar form. Formula for the area of surface obtained by rotating the parametric curve xt and yt, where t lies between t1 and t2. About x-axis and y-axis are given here. Sx, surface area of revolution t1 to t2 integration 2 pi yt under root of dx dt whole square plus dy dt whole square dt. Similarly, for sy, surface area around y-axis, this will be done. Now, evaluate the curve of the surface generated by the revolution of the cycloid x equals to a theta minus sin theta, y equals to a 1 minus cos theta about x-axis. This is the cycloid, and for this cycloid, limits of theta are here 0 to 2 pi. We can see our trace the curve graph. So from the given equations, x equals to a theta minus sin theta, dx dt differentiate. This is differentiating with respect to theta, and here differentiating with respect to theta. So we will use these equations. So we are writing here this is y theta, and we use surface area after revolution of the cycloid about x-axis, sx equals to 2 pi y theta under root of dx d theta plus dy d theta whole square d theta. After simplification of this, we obtain like this. This is the surface area. Now we have next question. Now we have this question: find the surface of solid formed by the revolution about x-axis of the loop of the curve x equals to t square, y equals to t minus tq upon 3. Here we will obtain dx dt and dy dt in this way, and putting y equals to 0, because revolution about x-axis. So after putting y is 0, we will obtain values of t like 0 and root 3, and therefore revolution about x-axis. So surface area Sx revolution about x-axis. By using this simple formula, we have 2 pi 0 to root 3 y under root of dx dt whole square plus dy dt whole square dt. After simplification, we will obtain the result equals to 3 pi. Now we have next form. Now we have practice question: find the surface of solid generated by the revolution of this asteroid x equals to a cos qt, y equals to a sin qt about the x-axis. One can apply directly formula and get this answer. Now we have polar form equation containing r and theta, then we have area of surface of revolution about initial line or x-axis, sx equals to 2 pi y ds. So it will be 2 pi r sin theta ds d theta, and y equals to r sin theta we are using here. So it will be 2 pi r sin theta under root of r square dr d theta whole square d theta between proper limits. We have this practice question for the purpose. Find the surface of the solid formed by the revolution of the cardioid r equals to a1 plus cos theta about the initial line. So cardioid looks in this way for this equation r equals to a 1 plus cos theta. For the upper half of the curve, theta varies from 0 to pi here. Now we have this simplification dr d theta equals to a 1 minus, this is minus sin theta, and ds d theta we will obtain in this way 2a cos theta y2. Therefore surface 2 pi 0 to pi y ds, and after simplification and putting the value of theta y2 equals to t, we will obtain this one 32 pi a square upon 5, 32 pi a square upon 5. Now we have some practice question in this way. Find the surface of the solid generated by the revolution of the lemniscate r square equals to a square cos 2 theta about the initial line. After simplification we will obtain 4 pi a square 1 minus 1 upon root 2. And if you are facing some problem finding the solution on or understanding any step, then you can comment and we will simplify again. Thank you.